Hello and welcome back to the channel. It's probably a pretty silly video to be releasing up on YouTube. Repairing a night light. This one actually has a photosensitive diode in it. I think it's on the base there. But anyways, the repair of this is rather simple. Just have a wire that came off here, and you would think, why would you repair something like this? Just go buy a new one. They're pretty cheap, and yeah, you're correct, they're fairly cheap. This one broke in a way that I can repair though, but more so I'm doing a video because I got a bit curious. I'll show you over here in the left hand corner. You can see that, you possibly tell that you have pins in here that these wires are soldered to, and they're, relatively exposed for the ability of small fingers to get into. And the base of this is not broke, actually. The plastic here has a little tab on the inside where it's essentially clips onto a plastic tooth over here to hold it in place. So I'm a bit curious as to the actual safety of our circuit board in here, and kind of wondering how safe this device is as a whole, to be honest. So not much to get into this. One screw coming out the front, and then we have an exposed circuit board over here. Pretty simple things. And perhaps I can pop this out just a bit without breaking anything additional. Now this has been unplugged for a good while. Not too concerned about. Oh, and I broke the other wire. Not to worry, we can solder them both on. Look, it honestly it didn't even break. The wires are just around these terminals, and even though there's solder sitting here, they were not soldered. Now this one obviously broke, but pretty sure if I wanted to, I can unwind this and pull it across. Well, if you're new to this channel and you enjoy the content that I'm doing, please consider subscribing. Give the video a thumbs up button. This is going to be a relatively short video. I do want to give a shout out to Mr. James DeLuca. If I said your name correctly, forgive me if I didn't. He put some good information on part 1 of the Zenith radio restoration series, where I went over basically theory of that radio. But yeah, go back and read his comments, because he explains in more detail how the circuitry, especially the ABC circuit, and works, etc. So really nice to get those comments. So thank you, sir, for doing that. But I'm going to reverse engineer this board for a second, and we'll be right back. Okay, and reverse engineering is completed. Now, I looked up this part number, if I can get this to focus. What is this? JCEM-1 94V-0. Does bring up some information. It's a pretty common circuit board design for multiple applications. In this application being used to drive some LEDs on a basically ambient light controlled, and I need to stand correct myself, not a photodiode, a photoresistor, okay, for enabling an LED to turn on when ambient light sources are low. So, a night light. That's the application for this. Something possibly else worthy to note, printed on the board, we have FR1 stamped right here on our PCB. Now FR1 indicates the design being comprised of a thin layer of copper over a non-conductive phenolic resin. So that's the build of our PCB. Okay. Input AC, live and neutral. Excuse me. And on the back, excuse me some more. Still working on getting over a cold, so rectifier, as well as the backside terminals to our photoresistor here. Several resistors, a couple transistors, NPN transistors, and a Zener diode. So we'll go over the schematic, try to essentially explain what's going on here. We have our input mains coming in, a 100 ohm resistor between our live to our bridge rectifier. Probably dissipate a bit of power. That bridge rectifier stamped MB6F, full wave bridge rectifier. Output being high voltage DC. I measured it. We're talking about 110, 111 volts DC being fed to our LED. Negative rail coming down through the bottom here. Okay. And then we have essentially our control or switching circuitry moving over, tied between the negative rail, leading back up to this positive rail where we have two parallel 220k ohm resistors. We have a Zener diode, which is going there to basically provide additional voltage regulation, get rid of ripple coming from our bridge rectifier. And then controlling the rest of the circuitry essentially for our path for current to flow to our LED. 110 volts DC coming through, or probably closer to 120 mains voltage, dropping down to 110 through this 5.6k ohm resistor to the anode of our LED. Cathode, we have two series 5.6k ohm resistors going to Q10. Stamped on it 1D NPN SOC 23 surface mounted resistor. We can see that its base requiring a positive is being controlled by Q1 stamped J6, another NPN SOC 23 transistor, and our photoresistor tied to the base of it, as well as a 13.k ohm resistor going between the base emitter, probably to hold conduction once once conduction occurs, in order to keep this on for a time period, driving this transistor or biasing this transistor. But we essentially see the path in which current can follow, right? Because we have a 0 ohm resistor also tied to our negative rail. So when Q1 is conducting, this path through here is connected, going through the conduction of Q2, so allowing current to flow back through and down to back through our circuit through here. But essentially that's all that's happening here. Obviously conduction to Q1 is controlled by the resistance of our photoresistor. So as ambient light is greater, I guess, or starts to get darker, the resistive value changes here, which has an effect on Q1. That's kind of it in a nutshell, or to the best of my ability to explain. But I would not call this a safe printed circuit board whatsoever. No matter the components we have on this, something worthy to note, there is no isolation between mains and our bridge rectifier sitting here. So you see no transformer. It's not something that's safe. I would also suspect traditionally you would have a capacitor in parallel with this resistor to allow any well, to allow our voltage to drain. Yeah, I'm just not and to consider the fact that we're talking about AC mains to this isn't low voltage DC. There's no further rectification. Excuse me, minus getting rid of a bit of ripple that's occurring over here. So this is not a low voltage LED. We have 110, 111 is what I measured being applied to these LEDs. And essentially that means that when this base, which is not glued down per se, as I mentioned previously, if it becomes exposed and pops off from the base, you have the potential of, you know, sticking your fingers between these two rails. Now, what you feel is what you're going to feel, but I wouldn't recommend it. So, even though it's pretty common design per se for you can find a lot of these types of devices across the internet, albeit I didn't find a schematic specific to this one. And the components on it are fairly common. The reason why it is enclosed and not exposed is to keep you from shocking yourself. So just something to keep in mind concerning the danger of this type of nightlight, especially if you employed it in, say, a kid's room or a bathroom or something like that, which is not very common for overseas, having, well, depending on what country you're in, having an AC plug or an AC outlet inside of your, you know, where your showers, your bathrooms and stuff are located. It's more common in America to see that. We also have them on GFCI outlets for safety. But yeah, anything near a water source, I think, you know, a certain amount of distance between an outlet and a water source in which you must have a GFCI. But neither here nor there. Again, I bought this at a local pretty popular hardware / home improvement store. So this was not a Amazon purchase per se, but this is what was being sold there and what we were using as night lights in my kid's bedroom. Now, I will repair this and glue the base back on and put this all back together to give it some functionality again, or to make it usable again. But you do what you want to do at your own risk, and I'll leave it like as that. Well, there we have it, folks. Repaired nightlight. About to plug it in and test it. If I haven't mentioned this already, happy holidays. Hopefully your holidays are well. Merry Christmas and Happy New Year to you. But yeah, let's plug it in and see what happens.
Mark?